example 1 for section 3.2, we're going to have this type of expression in our definition of a derivative we're going to do in the next example. We have a binomial, specifically x plus h raised to some power. And if it's the second power, we can use a little shortcut for that. But if it starts getting third, fourth, fifth power, binomial expansion with Pascal's triangle is a little bit more efficient. So just a reminder of Pascal's triangle, you got your handout. It looks like that. You just continually build on Pascal by having the ones down the sides. You get each next number, like here, for example, by adding up the two numbers above it. So you can build it down as far as you need to go. And the thing to remember about Pascal's triangles, whatever your power is up here should match the number in that second row of each object. So we can see that in this case, the 5 happens here, so these right here would be the numbers we use for Pascal's triangle: 1, 5, 10, 10, 5, 1. In the interest of having more room to work, I'm just going to cover that up. These do tend to get lengthy. So, if I want to build the expansion, this is term 1 positive x, this is term 2 positive h. The highest power is 5, and we're going to start the lowest power is 0 as we build these terms. So the first object is going to have the Pascal number 1. We take object 1x raised to the high power of 5. And we take the second object, positive h, raised to the low power of 0. Then you always put a plus sign with Pascal's triangle. So it's plus between every term. If minus is going to happen, it's going to be there's a minus sign in the expression. Again, the expression we're going to get specific is going to be x plus h to a power, so it's going to always be x and h over here for the sake of what we're doing. Second number in Pascal is 5, and then we take object 1x to the 4th power and object 2 positive h to the 1st power. So the power starts at 5 and it reduces to 4. Power starts at 0 and increases to 1. So it's just a matter of continuing to decrease the x power and increase the h power as we change the Pascal number. So our third term, we're going to go with Pascal number 10, and then x and h are going to be raised to the 3rd and 2nd power. Then we put a plus sign. Go with the next Pascal number of 10. There's x and h. We're going to reduce x to 2. We're going to increase h to 3. Then we put a plus sign. The next Pascal number is 5. We got x and h. We're going to drop x to the 1st power, drop h, or raise h to the 4th power. Put a plus sign. And the final Pascal number is 1. And that gets us x and h. X goes down to the 0 power, h goes to the 5th power. You should, just as a quick check, the power of x should start at 5 and end at 0. The power of h should start at 0 and end at 5. So 5 is the maximum power we get to in either of these. So if you pick the wrong row, you have too many numbers, too few numbers, that won't happen. So, and then all you have to do to get the answer is to simplify each term as much as possible. Recall anything to 0 power equals 1. 1 times x to the 5th. Plus 5 times x to the 4th times h. Plus 10 times x cubed h squared. Plus 10 times x squared h cubed. Plus 5 times x times h to the 4th. And once again, the 0 power makes 1. 1 times h to the 5th. And that would be the expansion of x plus h to the 5th power. And again, that just represents a step in the process of using the definition derivative of the polynomial function if we have a power, again, greater than 2.